This video is for AQA Further Pure Mathematics, Matrices 1, Section 4, using zero and identity matrices. Well, we start off by just looking at a couple of products that we wish to find. The first one are two 3x3 matrices, which if multiplied together then will give us another 3x3 matrix, so we'll have 3 columns and 3 rows. Now if we look at the matrix multiplication, taking the first row by the first column, you'll see that there are zeros apart from a 1 in the first column, so therefore the only part of the multiplication which is going to have any effect is the 2 multiplied by the 1, which gives us a 2. If we move along to the second column, then we can see that it's the second element in the column, which is a 1, and therefore the multiplication will just be the 4 multiplied by the 1, which is 4. And finally, with the third column, you can see then that it must be 0 multiplied by 1, or 0 in that position. So that the first row has just been left the same as it was in the left-hand matrix of the product. Now, as we move down, the same thing is going to happen, so that for each of the second and third rows, they're simply going to be repeated in our product matrix: -1, 1, 3, and 5, -2, 7. So we can see that the multiplication by that matrix on the right there has had no effect on the left-hand matrix. Turning our attention now to the second of the products we've been asked to do, we can see that this time that the right-hand matrix is completely zeros. So we're going to end up with a 2x2 matrix, because the order of each of these is 2x2. So that when we do that, we'll get 4 entries. But of course, because the right-hand matrix is zeros, all of these are going to be 0. Well, these two matrices that we've been using have got special names. Firstly, the one where we have 1s on what's called the leading diagonal. So we refer to this as being the leading diagonal of a matrix. And if that leading diagonal is completely 1s and every other entry is a 0, this is referred to as the identity matrix. Now the identity matrix obviously depends on the size, so they're always square matrices. 2x2, 3x3 are shown here. So an identity matrix will leave the matrices being multiplied unchanged. We can see the result that we had earlier. It's true also that if you multiply any matrix A by the identity, or indeed the other way around, I, the identity matrix multiplied by A, you will always get that matrix A. So it has, in effect, nothing has changed in the matrix that you're multiplying. The other matrix that we consider is one where we've got completely zeros. Now this matrix then is either called a zero matrix or a null matrix. So this is a matrix where every single element is 0. And then if we have a multiplication with conformal matrices where one of them is the null matrix, then every single element in the product is going to be 0. So indeed it must give us also a null matrix. Well, that's the end of this video. In the next one we will look at section 1.5, which considers determinants and inverses of 2x2 matrices.